Now see, in this question we have to find area bounded by, area enclosed by these two inequalities, right? So the approach is to plot this inequality on two-dimensional plane and then plot this inequality and find the area that, find the region, find the area that satisfies both of them, this as well as this, or we can say the common area of the two. So plot this, find area, plot this, identify area satisfying this, and take the common area because we have to find the common of these two. So let's plot this first. To plot this first of all we can plot the equal to sign, and to plot this curve we'll apply transformations, that if we can draw a graph of this, we can draw this because y is replaced by mod y, and we know how we have to modify graph when y is replaced by mod y, that is like reject lower half and take image of upper half in lower half, right? I will see that. Now from this to this, y by y plus half. So if we can draw the graph of this, we can this, and this is when we have to replace x by mod x. So we'll draw graph of first, and from first we draw second to third, and third to fourth. So e to the power minus x is graph which I'm sure you would know how to draw. Now we replace x by mod x, means whatever we have in left half, reject that and take reflection of right half into left half. So this is graph of second function, that is e to the power minus mod x. Now we replace y by y plus half, that is shifting this graph half units down. So you can see this intersection with y-axis would shift to half, and this asymptote, horizontal asymptote, which is y equal to 0 line, will become y equal to minus half line, like this. And we can find this point of intersection with x-axis, the value where this expression value of x or y is 0. So we replace y equal to 0, take log of both the sides, so minus log 2 equal to minus mod x. So mod x equal to log 2, or we can say x equal to plus minus log 2. So this value is minus log 2, sorry, plus log 2, this value is minus log 2. Now the last step is when we have to replace y by mod y. Y by mod y means we have to reject whatever we have in lower half, we have to reject that, reject graph in the lower half and take image of upper half into lower half, like this. So this is the final graph of the first inequality, but this is the graph of the equality, and we have inequality here. So you can see if I replace origin here, half greater than equal to 1, false. So origin does not satisfy this inequality, means we have the non-origin side of this inequality, means non-origin side of the curve we have plotted, that is this part. Now let's plot the second curve. Second curve is mod of max of mod x mod y less than equals to 2. Now the easier way of plotting this is, if maximum of these two is less than equals to 2, then we can say both of them should be less than equals to 2. If the maximum of the two is more is less than 2, then obviously the one that is less than the maximum would also be less than 2. So we can say both of them are less than equals to 2. Now mod x means x lies between minus 2 and 2, and this means y lies between minus 2 and 2. So you can see we'll get square, x lies between minus 2 and 2 and y lies between minus 2 and 2. So less means inside this, so area bounded is the square. Now if I just draw the other one, this is 2, other graph. Now the other inequality means region outside this, and this inequality means region inside the square. So common area is this area. Now to calculate this area of the square, you know the side length is 4, so area of the square is 16 minus 4 times this area, because basically I'm finding area of square and subtracting this shaded area with black, area shaded with black. And to find this area shaded with black, I'm just finding the area bounded in first quadrant. You can see area bounded in first quadrant. This is log 2, this is half, right? So integral 0 to log 2 this function. Now if we just go back to see the definition, we should have seen this earlier also. So we started with this e to the power, this is e to the power minus x. We started from here, e to the power minus x is e to the power minus x. Then we shifted it, we replaced x by mod x, we got this. Still it is e to the power minus x. Then we shifted it 1 unit, half y by y plus half units down, so it becomes y equals to e to the power minus x minus half, right? And then we flipped the upper half into lower half, image of upper half into lower half, but that didn't change the definition of this. So definition of this is e to the power minus x minus half dx. Now one thing more, like to plot this square, to plot this inequality, I followed the easier approach, but the other approach would have been that first of all plot region bounded by this inequality in first quadrant, that is mod x by x and mod by y. Once you have that, you can take reflection of that in both the quadrants, that is replace x by mod x and y by mod y. And now we'll have to make two cases, y greater than x, then max of this is y less than equals to 2. When x is more than y, or this, then x is less than equals to 2. So we can combine these two cases. This is y equal to x line, y greater than x, above this y, this is y equal to x line, this is y greater than x, this region is y less than x. In y greater than x, we have to follow y less than equals to 2, means in first quadrant, means this. Then we have like this is x equal to 2 line, right? When in y less than x, we have to take x less than equals to 2 in first quadrant, that is this, right? So this is in first quadrant. If you replace x by mod x, we reject left half, take reflection of right half into left half. Replace y by mod y, reject lower half, take reflection of upper half into lower half. This is another way to see that this region, this inequality bounds a square of length 4 units whose center is at origin.